Routing is like exploring the vast ocean, deep, dynamic, and full of hidden paths. But before we dive into deep and let's wade into the shallow waters first, this video is that gentle splash on the shoreline, just enough to get your feet wet and get you ready for the journey that lies ahead. In this, we're going to tackle routing in a quick session, covering what it is, how does it work, and why you should care. By the end, you'll have understanding of core items like RIB versus FIB, layer 2 versus layer 3, dynamic versus static routing. Plus, you'll get a free cheat sheet that sums up everything at a glance. That's just a sneak peek into the cheat sheet that I put together at the end that will come up, and it will show you exactly what you need. Obviously, we're going to start with why routing does matter. Routing is how each data packet finds its way from the source to destination across different networks. It's essential, like the post office system of the internet, ensuring your mail or data knows which path to take. Another simple way of imagining this is there are two LANs. Think of these two buildings, they want to talk to each other. The handshake happens with a router in the middle, where it's a bridge that moves from one side to another. The idea is I'm making sure that the data travels from point A to point B. Now, another quick thing to remember here is when you have a router, each interface represents a layer 3, which means a separate network. When I come into a router from one interface, which network am I trying to go to? That's your next hop. Or I would also say the default gateway. So next hop means if I'm trying to go to network B, then the next hop should be this door right here. Depending on C and D, I pick up this. If I'm trying to go to network E and there's nothing mentioned, then there could be a catch-all door, which would be, let's say, the blue door or the default gateway, which means if you have a network that's not listed, then just take that door and eventually that will take you to the internet. Now, a good example of that is when people are trying to set up something to go to the internet because you're not going to mention each and every route that exists onto the internet. That's pretty much how you need to think about this. Now, there are some core terms and concepts. For example, router versus routing table. See, router is a device that forwards packets based on IP addresses, and it maintains a routing table to decide where that next hop is going to be. So they're tied together. So think of a router as a device. Routing table is like a table that it has that tells it all the possible destinations and how to reach them. Another very important concept to keep in mind is when we're talking about routing is routers generally work on layer 3 because they deal with IP addresses. So packets are addressed with IPs at layer 3. Frames are those packets that are at layer 2. Now routers, as I mentioned already, focus on IP addressing, not the MAC addresses, right? So that is an absolutely important thing to understand and keep in mind. Next, let's move on to what's routing information base, which is RIB, and forwarding information base, which is FIB, which is the data plane. The RIB is where all learned routes, static, dynamic, etc. live. It's the control plane. FIB is the hardware-based super fast lookup where it uses specialized memories in order to make sure you throw all those routes out much, much quicker. If you think at this diagram here, this is a routing table that will be filled up by either manually somebody configuring it or a dynamic routing protocol that learns around it and feeds it. So this is, think of that as a list. Fib is more like, think of a second guy who has this gun and who's just shooting all these packets out much quicker because that's where your speed is needed. Okay, so now moving on to static versus default versus dynamic routes. Static routes are manually configured and they work well with small or a simple network, but they do not scale well, as you could imagine. If you grow, it's hard that how many can you configure, and also don't forget they don't converge. So if there's a link failure, you'll have to manually intervene and give it another route. All right. Default route is catch-all. Path when there is no specific route matches, it's your router's fallback option. An example would be 0.0.0.0/0, which means for an IPv4, let's send a router traffic to everything else out a particular interface or next hop when there isn't any more specific route available. Dynamic route, things like OSPF, BGP, let routers share route automatically, ideally for large or changing networks. Now, there are a few more protocols that I didn't mention, like EIGRP or ISIS. Now, all of them are actually dynamic routing protocols so that routers speak the same language, they learn and exchange routes automatically, enabling the network to scale without any manual updating of every router. There are certain other things you will see in the cheat sheet. There are these matrices and matrix types, which are like the hop counts, cost, and administrative distance. What are these things? All these matrices are basically based on which route should I prefer, based on hop count, how far is that particular router, what's the cost, which means is the path a 10 gig path versus a 1 gig path. And then you have something called as administrative distance, which is think of that as a tiebreaker mechanism when using multiple routing protocols or static routes, and they offer the same route. In case of a Cisco, the lower distance or a preference in case of a Juniper wins, and that one goes into the forwarding information base. More specific versus less specific. Now, in IP routing, when two routes match a destination, example a /24 or a /30, the more specific or the longer prefix router is chosen. For example, if you have a /30, which is more specific, that will be chosen as compared to 2. And convergence and scalability. The process of all routers updating their routing tables in response to a change in a network, like for example, if a link going down, so that everyone again agrees on what are the valid paths, is convergence. Is understood where, for example, the static routes don't scale well because I can only manually put so many routes as a human. And also, if something fails, it's not easy for me to every time be reactive. That's where I need to understand about the scalability. Now, another option is edge versus internal. This is where internal would be your internal gateway protocols like OSPF and ISIS, or even EIGRP if you're operating inside an organization using Cisco specifically for EIGRP. Edge would be your EGPs like external gateway protocols like BGP, the most common one, connects different administrative domains, example, your own enterprise ISP to the other wider internet. And to move beyond static routes, that's something you need to understand when you're doing your labs. Yes, you're doing everything, you're doing static, you're doing dynamic, but you have more than a handful of routers or frequently adding or removing subnets. Consider dynamic routing protocols. Manual configuration will not scale. The routing protocol. So OSPF is a common choice for most enterprise with single area for simplicity. You will rarely find in real world not so stubby, multiple areas. There is a logic behind that is because the routing domain can be only so big. When I'm using multiple domains, I'm basically, because in protocols like OSPF, the entire routing database is shared with everybody. That means that much more routes I need to store in the router's memory. So the smaller the database, it's better. I can quickly search it up. So that's where the scalability part comes in. How big is my database? If it's too big to manage, then it's a problem, right? Now, BGP is essential, as I said, a multi-homed internet connection or advanced data center. That's where BGP gets used, or even the newer technologies like EVPN and VXLAN uses that. EIGRP, yes, still around, but not all the networks are Cisco, so you won't see them all very often. It is more popular within the service providers, not too much in the enterprise side of things. Something important to remember is all these routers can run specialized operating systems. For example, Cisco has multiple variants: Cisco iOS, Cisco XE, Juniper Junos. They are specialized operating systems. They run routing processes like BGP, OSPF, etc. As spoke before, the convergence speeds do matter. For critical networks, sub-second or even microsecond convergence can be important, especially in a financial or a service provider scenarios. So tuning protocol timers or leveraging features like BFDs, bidirectional forwarding, which is part of BGP, by the way, can drastically shorten your failover times. Another thing is to keep in mind is exam versus real world. Certifications will often teach you how to configure many protocols in details, but real world networks rarely use them all. Focus on the more relevant protocols, often OSPF, BGP, and sometimes EIGRP, and on the design principles like fast conversions, resilience, and scalability. And there you have it. Now you have all the essentials, no more guesswork on data magically travel across network. Here is your free routing cheat sheet that summarizes everything we covered from RIP versus FIB, static versus dynamic. Make sure you take a screenshot. And if this video helped you, please hit that like button and consider subscribing. Thanks for watching. Happy routing. Bye for now.